Well, hi, good morning. Thanks so much for joining me in my shop. Ready to go another step with this car radio. And I was getting ready to set up for an alignment on it. I used to start doing that. Of course, part of that is having this indicating meter here, output meter. And I was just getting ready to connect the leads. I was going to connect them to the speaker terminals, and it raised a question that I think I want to settle at this point. That's interesting. Off the magnet of the speaker has come the little tiny piece of carbon slug from the last radio I was working on, which I lost. I found it, stuck on a magnet. Surprising, this stuff would stick to a magnet. Okay, anyway, not to get too distracted here. Just take that off for now. So let me show you what I'm talking about. What has been bothering me a little bit, and I think at this point I really need to settle it down. So this is the connection to the speaker here. And you can see this is a 3-terminal plug, if you like. And 3 terminals, only 2 of them are being utilized because this speaker has a permanent magnet on it. The last terminal is to convey some DC current into a coil on the speaker instead of a magnet. The older speaker must have just had a coil here instead of a magnet. That coil needs a little bit of current going through it to generate the magnetic field, make the rest of the speaker work. That was coming from here. Or was it? Because when I look at this on the schematic, what it says to me is that these wires are not installed correctly. And if you want to pick up the voice coil, it's between these 2. Actually, this is the one that conveys the well, let's look at the diagram, because I think I've got it all messed up in my head. So that's why I need to do this, to unmess it. Okay, so here's the schematic. We're very interested in this area here and the radio connector here. So that's a speaker connector and the radio connector. Let's see if can I manage to zoom in here? I think so. Okay. Ooh, that's a little much, isn't it? Not the best diagram. Okay, let's leave it like that. So here you see the old style speaker with the field coil producing the magnetism for the speaker to operate, and the voice coil carrying the sound signal from the radio. So in this radio, this coil is missing because the speaker doesn't have one and it's not required. So if we look at the connections for this coil, follow this one wire down very carefully. It comes to this. Now what are we looking at? Prong view of the speaker plug. Okay, so that's a field coil down here. If we look at the other side of the field coil, you can see that it's attached to the voice coil. This is just a common wire here that's being utilized for both things. Come along here. Look, it connects to the shield on this wire. Well, there is no shield on the wire in the radio because it's all been replaced. You follow the shield down and you see the shield is connected to this pin. So if you look at the way this is structured, these 2 and this guy over here. So we come down here, look, these 2 and this guy over here, look what he does. He just goes to ground. So basically this is a grounded point here to the chassis. And the voice coil is getting its signal from this terminal. So right now, the way the radio is wired, the voice coil is connected between here and here, not between, get this right now, not between here and here, between these 2. So if we follow these back, these 2, this gets scarier and scarier. So here we see the output from the transformer. Okay, that makes some sense, being fed off through the speaker and to the chassis, I would think. But in this case, it's through the speaker and over to this wire. Now, where's this wire go? It's down here. Okay, jump to X. The X is over here. What? So what's happening here? This is being fed almost directly from the battery. You just follow back through these coils, low resistance coils, on-off switch, right on back. So there's 6 volts here. 6 volts would only drop very slightly through these coils, if at all, really. 6 volts. And of course, what's it doing? It's going to the heaters, and it says right there, speaker field coil. But it's not going to the field coil. It's going to the speaker. Or is it? That's the question. So if I accept the way this is arranged here in the diagram, what I have to accept is that the speaker on this radio, the way it's wired right now, has got 6 volts across it all the time. 6 volts on a speaker like that, that's not a good thing, I can assure that. So I want to sort this out, because I really think the speaker should be disconnected from this terminal and reconnected over here. But it works, to my surprise, and I've never heard any loud pops or anything that would suggest to me there's 6 volts going across that speaker. Okay, so let's investigate on the radio itself. So the first thing we can do is we can make a couple of, see the pattern there? So this top one should be grounded. Supposedly the top one just goes right to the chassis. So let's do a test or two here and see what we can figure out. Now, frankly, I've poked around with this already, but often when I poke around, every time I poke around I get something a little different. So let's try it again. So what I'll do first is let's look for ground. So I'm going to put one side of the meter on the chassis. Kind of stupid leads I'm using here, but they'll be okay. And the other side on these different terminals. We'll start with the one that supposedly goes to ground. 1.8. Well, let me just short this out here. Yeah, so 0 is 1.8 using this. So let's get rid of these. These get me in trouble every time I try to use them. We'll use some real McCoys here. Whoops. Oop, this isn't a real McCoy. What is this? That's a fake McCoy. There we go. That was a Hatfield. Here's a McCoy. You see that? That's coffee. A little more coffee. I can probably play professional baseball. Now we're getting somewhere. Okay, so that's pretty much a 0 there. Let's try again. Now we gotta hold this on here. Okay, so that terminal appears to be grounded. Now I still have the speaker plugged in, so keep that in mind. It's a 4 ohm speaker, or so it claims. Now we'll go to the other 2 terminals. That's pretty close to a 0 also, isn't it? And this side, 0.4, and back to the supposedly grounded one. So we're probably reading the resistance of those coils. I'm going to say little coils, little resistance in the coils, but they're big coils. So according to my reckoning right now, where I'm reading this resistance, there should be 6 volts there when the radio's operated. It should be right across the speaker. Well, I've run this radio quite a bit with the speaker on. Nothing, smoke's come out of it. So let's run it again and see what happens. Just double check my connections here. Radio's off. And I'm going to pull this out just to
just to settle it. Okay, I'm going to be eventually energizing this radio from power supplies anyway, so I don't want that in there. And likewise, I can pull this tube out, really, a rectifier tube. Okay, found the pencil. Now they're supposed to be hard to get out, right? They're locked in. There it goes. Okay. Now back to the speaker issue. Why don't I let's operate it with the speaker on. Why not? Listen carefully for any of those pops or clues that there's a 6-volt shock going at that speaker, but I just don't believe it's possible. We're off. Okay, I've switched on the power supply. I was just thinking, wow, okay, yeah, sure, the 6 volts would be there regardless of the rectifier tube or the vibrator. Okay, so the objective here is, this is positive ground, so we should see a negative. So if I do it this way, we should get a positive reading on the meter. Okay, pop on. So there's the 6.3 volts coming into the top of the fuse. No such 6 volts here, so I don't know what's going. Oh, there's the 6 volts. So the radio, and so what I'm doing here, so you can see what the voltage is there. I'm touching now the terminal that's not being utilized, and that's where the 6 volts is. So it's just a matter of the schematic doesn't quite match how this radio is operating. So this is correct. I'm pretty sure if we'd hooked the speaker to this 6-volt terminal where I have this right now, that speaker first of all would make a lot of loud pops as you turned on and off the power, and secondly, 6 volts is probably too much for that speaker. I'm not really sure of that, to be honest with you. But, sounds like a lot to me. 6 volts steady DC, gotta be bad, but not a concern. Okay, great. Now we're on our way now to doing an alignment finally. So I have looked at the alignment instructions, and like most radios, the sensible thing is to start with the IF. So we're going to do that. This radio's IF is 265 kilocycles. We'll set up for that, and then I've got to feed it into pin 6 of the 7B8. Let me just make sure this is, I switch this off. Switch off the power supply, because I'm going to have to set up the B+ supply too to get this going. But I also have to feed into pin 6 of the 7B8 with a 0.1. With a 0.1. Okay, here's a 0.1. Here's a 7B8. Just move this a little bit here. 7B8. This guy down here, kind of buried. Oh boy. I said pin 6, I'm pretty sure. When I'm pretty sure, that usually means I better double check pin 6.
6, eh? Trying to spot the key. I really can't see it. You know, it doesn't really protrude down into the bottom. The tube pulled out, you can kind of look up in the socket and figure out where it is, but I can't do it this way. So I need to figure out one of these pins based on connections to it. So there's 2 resistors right here, and one of them looks pretty sad actually. There's 2 right here. This is like a 50 something K, and this one looks like he needs to be changed. He's looking beat up, and that's a looks like a blue 3rd band. Really, blue 3rd band. So anyway, let's see if we can spot 2 resistors coming off of one pin on the 7B8. Okay, 7B8 converter tube. This is where we want to punch in the 265. The pin number 6. They haven't numbered the pins here. Oh well, that's not going to help much, is it? Let's see. 2 resistors. 2 resistors. So if we follow this all the way over here, we have this weird thing here. We have this weird thing here, which I never sorted out. 10%, I think it says 800 ohm, 10%. Okay, but no 2 resistors. I'm not finding. Look, there's a connection right there. I missed that. That didn't work. Oh, this wire could have resistors all over the place here. Run that way. There's one this way, but none that way. This guy comes down here to the capacitor. This guy comes down here to the resistor this way, but there's none the other way. What? This isn't working. This didn't work. I'm looking for a pin with 2 resistors coming right off it. Down here. No, I already did that one. Well, that didn't work. Okay, let's try another one. So there's a connection from the plate that goes to T1 here. Can we spot that? Is there any other similar thing going, something going back this way? Which we could maybe mistake it for. Let's try that. See if we can find P, plate. Blue wire. Okay, blue wire. Let's see if we can find it.
Blue wire.
Get a lot closer yet. Anybody see a blue wire in there? So you can see a couple of these resistors look pretty rough. They really have that look. That's this one here. And this one here. They don't look so healthy. What I'm really looking for is, there's that a blue wire there? Is that blue? You know, the wire may not even be blue anymore.
Okay, so where's the local nearby IF can that this is going to? Okay, so it's over this way. The IF can is, see those wires going up that hole? I don't see any blue wire. It's a little up from there. Not that hole. Yeah, it's just under all this stuff. Right. This is kind of hopeless. This is a hopeless approach. This is a hopeless situation. Give me another approach. Figure out the pin numbers on this tube. Why did it not match at all? Wow, it's just so buried under there. I can't really. This is a silly situation, isn't it? Well, let's see. Where's the grid coming from? I'm just going to peek myself at the grid wire on that tube is coming from. Yuck. Yeah, I'm not going to be able to find that. Huh. Anybody. Okay, so let's look at the value of those resistors. I've got one here, it's 15 megohms, half watt. 15 megohms, that should be easy to spot. 15 megohms. So one of these would be 15, so 15 would be brown, green, something. Brown, green, something. Brown, green, something. There, brown, green. Doesn't look right. Brown, green looks like orange. Oh, that's right. An M on here is a K. Right, an M is a K. So that's the guy right there. And there he is going right down to one of the terminals. So we found something. What did we find again? What was that? And it's in bad shape. How much do you want to bet? Anybody want to make a bet? Just bet. Just bet on anything here. Okay, I'm just going to peek at the schematic myself. Remind myself what I'm doing. 15K. That's G4. How much you want to bet? That is a 135 volts DC on that line. Yeah, you know what? That's got to be a shield. The screen, rather, screen. So makes it, okay, so screen, wow, this is just the stuff. For sure that's the screen? Sorry you're staring at that while I do this. Well, 7B8. 7B8. Wow, this is just, what should be fairly easy. 7B8 pentagrid converter. G4 screen. Pin number 6. So we have apparently identified pin number 6, and what we are actually after is pin number 4. No, you said pin number 6. I said use pin number 6. I said use pin number 6. Didn't I? We're going to put this in on the screen. Pin 6 on the socket. Pin 6, 7B8, pin 6, G4. G4 is the screen grid. Okay, let's do that. We'll use the screen grid like it says. As long as we have a capacitor, we're okay. I think. So pin 6 is the resistor that we were looking at there. Here, let's go back. Pin 6 is this horrible looking resistor. So let me settle the pin 6 connection first. I think that's okay. I'm going to just leave that resistor as it is right now. Oh wow, it is pretty bad looking, isn't it? These typically are, it's a very low wattage resistor, and it's in a current carrying position in the radio. Okay, so we're ready to feed in the signal. I'm really hesitant. I'm thinking we should really deal with this resistor problem. You know what, I can't do stuff like that really until I have the vibrator. And we get the B plus the vibrator generates. Because right now I'm going to be using a fake B plus to do this test. Okay, fake B plus. Now we need the fake B plus. Second here. Fake B plus. Remember, this one is not positive ground. And the other end goes into the start of the high voltage. Where did I put it last time? That was so clever that I cannot remember. On the top of these two capacitors. Hang on a moment here while I try to sort that out. It's right off the K of the, well, that's another way to identify, oh, that's the wrong tube. Okay, off the K. Off the K of the rectifier, off the cathode of the rectifier. Okay, cathode of the rectifier, I'll get this right. Rectifier was B. Rectifier. Yeah, it's let me read it right off the top here if I can. I pulled it out. Duh. 7Y4. It's okay. We'll get there. 7Y4. K is pin number 7 of 8 pins. Okay, don't get any of this confused now. Pin number 7 up here. Okay, so the tube is out so I can see the key. I think I can. Okay, so the key is straight this way. So pin 7 is right there. I seem to remember that. We're putting the plus on the 7. Putting the negative on the chassis. Oh, this isn't getting the right wires. Come on. plus. Pin 7. That should do it. Okay. Now we need to hook up here. This is the output from the signal generator over here. Gain the negative to the chassis. Ground, I shouldn't really say negative. This guy's going to be right there. Okay. So I want this guy set to 265. Okay, so we're in the range of 265. The signal level's quite low to start off with. I think we're all set to go. Switch is here. No antenna connected at all. We don't need it. I think we're ready to go. Oh, I don't have the output meter connected. Now that goes right back to the reason why I even got curious about this, because of the possibility that one of the terminals coming here was grounded to the chassis. One of them is grounded to the chassis, and the one that is which one? The one that is. Does it really matter? I think I just want to not mix the ground terminals up on these instruments. Back and just double check and make sure I know which one of these is chassis ground. I think it's this guy. 0.2. I don't think it's this one. 0.5. Okay, 0.4 is the lowest we can get there, and on the other side 0.2 and 0.1. That's got to be what the meter's doing. 0.2, 0.1. There we go. So I know which one is chassis ground. That means I'll understand the cause of the accident when I'm writing the report afterwards. So ground, I can just pretty much go right on the chassis here. Wait a minute, black wire, go the other way. Go down here. This is much easier down here. Right at the speaker. Whoops. Ground is the black wire. This one right here like that. So the meter goes down. Okay, we'll leave it like that. I think we're all set to go here. So if this begins to work the way I intended to, then we're going to hear a tone coming out of the speaker. Okay, that's off. Power on. Oh, we don't have power monitoring. That's okay. I've previously set the 6-volt supply appropriately to deliver 6 to this radio. And where is it? Is it on, what's it? Doesn't matter where it's tuned right now. That's not an issue. Whether it's on manual or automatic doesn't matter. I have the whole radio ready to go, but spun around the wrong way. Because the things we need to adjust are on the other side the radio. Going around. There we are. That's these guys here I've got to adjust. So I haven't got it switched on yet. Just letting my DC power supply, my high voltage supply, warm up a bit. Where we start. might have trouble with these leads. I'll have to deal with it if we do. Okay, so we're going to switch on, and the hope is I'm going to see a couple of amps flowing into the radio. There we go. Okay, there was a leap up to about 6 amps briefly, and now it's down around 2. Perfect. That's suggests to me that's just the current going in the heaters. We're heating up the tubes. Now we'll start applying the B+ voltage. Remember the last time got up close to 100 and we could hear it. So volume up. And voltage going up. Right in here. Anybody hear anything? Of course, we may not hear anything now because I don't have an antenna. And I've got this connection to the grid of the tube. Go a little higher. Oh. Okay, so I'm O-ing because of the current flow here. Absolutely indicating there is a resistor to ground somehow. Okay, not to worry about that just yet. That might be normal. Getting the same kind of readings we got last time around. Not a sound coming out of it now. Maybe that's because the 265 is way off. Or it's just not strong enough. It's probably more likely. So let's fool with this now. Expecting to hear a tone. Anytime. Okay, so it's got to work on this setting. Okay, so we have failure to launch here. Why exactly? So we're not getting any hissy sound out of the radio. We're getting current flowing from the big DC high voltage supply as if it's across a resistor. You know, I think I've got this, I think I have the supply hooked up wrong. I would say that's what's happened here. So let's go through it again. I've turned down the supply voltage here, so I turned it right down. 7Y4. Anywhere along the line I could have booted this up. 7Y4. 7Y4. Pin 7. Cathode. Why do I care about that? So I'm looking for the place to inject the high voltage. Pin 7. Pin 7. So looking through the tube socket, I can see where the key is on the tube, the empty tube socket. That clearly identifies pin number 8, and I'm right on pin number 7, no doubt about it. I've got positive, negative done right. And we got nothing. So let's do this. Let's remove this. Maybe this is wrong. Okay. So these tubes are still hot in this. So we should get the result we got last time, which was a hiss. Let me plug an antenna in. Get back to where we once belonged. Okay, got an antenna. Volume up full. Let's give it a little B plus action here. That's pretty reassuring. Now, let's Is that a very low B plus too? Perfect. A much lower current. It's good all around. So why no signal coming out? And I put it into the IF because I hooked up to the, it just doesn't make sense hooking up where I hooked up according to these instructions. Something's not making sense. It usually means when smart people wrote this stuff. So if it doesn't look smart to me, I'm willing to bet it's me. Signal from the generator through a 0.1 dummy to the 7B8 converter to pin 6 on the socket. 7B8 pin 6. 7B8 pin 6. G4. It's clearly a screen. You know where I'd rather be? I'd rather be either pin 4 or pin 3. 3 or 4. Let's try pin 3. So if I'm on 7, I just count over and find pin 3. Okay, radio's on, B plus down. Okay. Yeah, I really don't understand that. Never seen it where they've invited you to pump a signal in on the screen. I don't see why you couldn't do it. Okay, so pin 8. No, pin. I'm all messed up here. Pin. Where were we? We are on pin. Oh my gosh. We're on pin 6. We're not on anything because I disconnected. So I know which one's 6. Count up from 6. Count up from 6. Oh boy, it feels kind of scary. 6. I was not on pin 6. I was on pin 7. I was on pin 7 based on what I learned about how these sockets are structured here. I think there's a hint on where the long thing coming out. Oh, well, I'm way off on which pin's which here. Okay, so way off. So that would be pin 1, 2, 3, 4, 5, 6 is way up in there. Oh my gosh. Should try pin 6. The real pin 6. Would the real pin 6 please stand up? Try it again. 1, 2, 3, 4, 5. Pin 6 way. Pin 6. I don't know. Gonna get pin 6 that way. I don't think we're gonna. Let's try this. Pin 6 it is. Okay. I think I'm on pin 6 now. Turn it way back. Take the B plus up to where we know the radio works. Let's pull this antenna out. We don't need the extra help here. Okay, we'll take it up to where we know it works. I think it works. That's got to be in the working range there. I'm just adjusting the supply. Volume's full. Okay, 265. Let's hear you now. Once again, let's hear it. Come on, sing to me. There it is. Way off. It's way off. It's way off. That's why. It's be 265. So what this is an indication of is two possibilities. So this is at 240. Let me put it back on there. I don't think we're going to be able to use these. It's not going to help. So there's two possibilities here. One is, let me get a really good read. I know I won't have trouble with. So one possibility is this radio's IF is mistuned on purpose, and it's to compensate for a dial accuracy problem. So somebody just hook this onto the speaker here. Somebody wanted to make the dial accurate, and they pushed the IF off to compensate for some other kind of problem. The other possibility is somebody tuned the IF by ear without instruments. That's more likely the case. I guess there's a third possibility. It's just drifted on its own. So we're going to push this back to where it's supposed to be. Quite important, this radio has a tuned front end. If the IF is tracking in an independent, or not independent, accidental frequency, it's not on 265, but it's on 245, then the radio's sensitivity may just drop into the tank because the radio is sensitive for a different frequency from what the local oscillator is now targeting. You can kind of have to add a little bit of your own brain power into that statement to sort it out, but that's what could be happening. We have a forever weak radio here, or we'd have to discombobulate the front end to match the mistracking, if you like, or misalignment of the local oscillator. Okay, so our objective here is to get the highest reading on this meter possible when this is set to 265. We have 4 coils to adjust. If I adjust any one of them far out from the others, nothing will come out of this radio and we'll be lost. So this is a bit of a journey on this one. So what I'm going to do is I'm going to blast the radio with a signal from the signal generator. As soon as I get it to stay put. Too many things pulling in one direction here. Okay, this might get noisy. Nope. Okay, that's a little better. Power wire. Oh, look, I do have a longer power wire if I just do this. There's a tangle up. Wow, okay. Good enough. 1, 2, 3, 4. Second IF, first IF. We start here. And what I'm going to do is I'm going to move the signal generator in the direction we want to tune the radio until I can't hear it here anymore. I'm not seeing it here. Seems a little wonky, doesn't it? Cannot have wonkiness while we do this. So I'm staring right at this meter right now. That's what I'm doing. So it's just drifting up and down a wee little bit. Oh, okay, so sudden jumps don't matter so much to me. It's a slow drift up or down that is going to wreck this. Okay, so it's just moving a little wee bit. I think we can ignore that. Let me turn this down so we're not hurting our ears so much. Make the meter more sensitive. Okay, so now, it's liable to be even more erratic because I'm down in a more sensitive zone here. It could even be the volume control. That's I don't know, good enough. Okay, back to what I was going to do. I'm going to tune the signal generator towards where I want to go until this fades out. I still hear it. I'm going to turn it up. Okay, so I can still easily hear it there. So now I'm going to bring it up. Start with this guy here. I hope to bring it up. Let's see what happens. Hold still, meter. Now we only have to do this roughly. So it's the last one where we have to be a little more precise. Wow. You know what? Blowing our ears off here. That was the second one here that was really big difference there. Okay, now with that we can probably make it to 265 on here and still hear it. .265 is actually 263 on this counter. I can still hear it. Let's go back and bring it up again. So we'll go through fairly quickly first. I'm just kind of doing it by ear here right now. Okay, this seems to be the big guy. The boss. Okay, now we're at 263. Turn this down. Down. Up on the volume. Okay, now we go do it one last time. That's probably the meter control, meter dial itself here. Yep. Okay. Up. Up. Come on. Very good. This one here up. Now these ones, they didn't seem to require any adjustment. That's a little odd. How does that work? Pretty sure that's going to be the end of the road there. There you have it. IF tuned way up. So the fun thing to do now is to put an antenna on it and see what we can hear at this point. Okay, good idea. So first down on the B plus before something bad happens. Out on the, down on the volume, that's for sure. Off the screen. Okay, in with the antenna. This is a piece of crud antenna I'm using. Okay, and just basically it's a piece of wire thrown around my shop about 10 feet long. Okay, up on the volume, up on the B plus. Way down. So this is one of the presets I'm actually tuning. It's not in manual mode. Right in this range. Come on. Come on. Get me a radio station. Come on. Okay, so since we heard no station there, what this is suggesting is the radio was, the front end may have been aligned to match the misaligned IF. So in fact, by correcting the IF, I have now got a large misalignment in the radio where the IF is essentially tracking one part of the band and the front end of the radio is tracking another. So they're tuning two different things, right? And nothing's getting through except all those noises, which is probably what's going on here. So the next stage of the alignment process involves a bunch of little coils and stuff, I think. I'm not exactly sure. I got to read up on it. So, but not to worry, this is coming along quite well, really. Fantastic. Okay, so thanks so much for watching, and we'll see you. I'll probably do the rest of the alignment on the next video. See ya.